Welcome to lesson 4.2, circumference of a circle. So in the last lesson, we talked about the radius and the diameter of a circle, and today we're adding in the circumference, or the distance around a circle, and really the relationship between that and the diameter, and also the radius of a circle as well. So if we can just take a minute here to review kind of what we talked about last lesson, I'm going to draw a circle right in the middle of the page. And if we can remember that the distance across a circle when it crosses through the center point is called the diameter, and I'm just going to label that as a D. And then any distance from the center point to any part or edge of the circle is the radius. So I'm going to label that with an R. And then the third measurement that we're going to look at today is called the circumference. But essentially that is, and I'm just going to use a different color here, the circumference, so I'll just label that with a C, is the distance around the circle. So it would be that measurement the whole way around. And there is a relationship between the circumference and the diameter. If you are to look at any circular object, anything, it can be the bottom of a can, it can be a roll of tape, any circular measurement will have the same relationship between its circumference and its diameter. So if you were to measure, like let's say using a string and a ruler, the area or the measurement around the circle or the circumference, and then you were to measure the diameter of that circle, for every single circle, when you take the circumference and you divide it by the diameter, it will always, always, always equal about 3. And I'm just going to rewrite that kind of using a formula, and I'm going to reiterate that statement one more time. So for any circle, the circumference, which we would identify as the letter C, the circumference divided by the diameter will always equal about 3. And the 3, if you actually measured an object, you would notice that it's not always 3. It's probably a number with some decimals after. But it will, if you're measuring very precisely, this number, which may look familiar to you because we've talked about it in math before, 3.14159, you'll see a whole bunch of numbers after the decimal place. We call this number pi. So the general rule is that for any circle, the circumference, I'm just going to get my point here, the circumference divided by the diameter will always equal pi. So this idea of pi might be new. You might have heard it before. You might already know a little bit about pi. But pi is a symbol for a number, and you might see that symbol on your calculator. It's a Greek symbol, and we call it pi. It's spelled P-I. And basically, pi represents a number with an infinite number of decimals. So if you recall when we did our pi competition a month or two ago, the numbers after the decimal place go on forever and ever. In the first few, you might have memorized some, 3.141596535, and it goes on and on forever. For our purposes, you can use the pi button on your calculator, but pi will equal 3.14 if you don't have a pi button on your calculator. So we're just going to remember that to the 2 decimal places. Pi is a decimal that never repeats and it never ends. So there's no pattern to the numbers after the decimal place, and they never stop. Pi cannot be written as a fraction, and for this reason, we call pi an irrational number. An irrational number because it can't be a fraction, it never repeats, and it never terminates. And pi is going to come up quite often when we are looking at circles, because like I said in the previous slide, the relationship between the circumference of a circle, or the area around a circle, and the diameter of the circle equals pi. So you will see this number coming up again and again. So if we know that the circumference divided by the diameter for any circle will always equal pi, we can rewrite this equation or this formula So it will better help us solve for circumference, because in this lesson there's going to be many questions asking you to find the circumference of a circle if you have the length of the diameter or the length of the radius. So there's a couple formulas in this lesson that you will want to pay close attention to and really get a lot of practice out so those formulas stick in your mind and you don't forget them. So we can rewrite this, circumference divided by diameter equals pi, we can rewrite it so that circumference essentially equals pi times your diameter. And if we think back to when we did our units on equations and solving for variables, the way we come up with this equation from this one is if I look at our original one, c divided by d equals pi. I'm essentially trying to solve for c. How do I get c by itself? I want to solve for just what circumference is. So I would do the opposite operation here, which we know is division. So I would multiply by d here, and what you do to one side of the equation, you do to the other side of the equation, so I would multiply by d here. So then that leaves us with c equals pi times d. Just a quick explanation of how we get from point A to point B. But really, this is the one kind of formula or equation that you'll need to remember for this unit, that the circumference of any circle equals pi, or 3.14, multiplied by your diameter. Those two numbers will give you your circumference. In the situation where you have your radius of a circle, and we would like to figure out the circumference, we know that the radius is half of our diameter. We could figure out circumference equals pi multiplied by your radius times 2, or 2r. Let me rewrite that. Your circumference equals pi times 2r. And essentially what I've done is I've just taken our diameter and I've just said your radius times 2, because we know that's true about our diameter. Our diameter is our radius multiplied by 2. Or we could write this as circumference equals 2 pi r. Again, it's exactly the same thing. I've just kind of taken the actual symbol of multiplication out there. So these are the two formulas that you'll need to become pretty familiar with for this lesson when solving circles. So on the next slide, we are going to just do an example together of how we would use these equations and these formulas to figure out the circumference of a circle. So we're going to start this example. I've just written the two formulas from the previous slide on my paper here. So circumference equals pi times diameter, or circumference equals 2 pi r. And these are going to help us when we're solving for circumference. So let's look at an example. I'm going to draw a circle. And let's say this circle has a radius of 1.4 centimeters. And my question asks me, I would like you to find the circumference of this circle. So I can use either of these two formulas to solve for the circumference. So I know that I have the radius, and really I could use either of these equations to figure it out. Let's use this one because I have my radius already. My radius is given to me. So essentially what we're going to do, just like in previous units and previous lessons, we're just going to plug in what we know into the equation. Let me just use a different color here. So I don't know what my circumference is, so we're going to leave that as a c. We're going to leave 2 as a 2 because that number is already given to us. Pi is already a number that's given to us. And then I just need to plug in the number 1.4 because that's my radius, and I can plug in my radius for the letter r. And then I just need to go through and solve this equation now. And so for this lesson you can use a calculator. So what you would type into your calculator is just the exact equation. This involves more than one step, but remember order of operations. And what this equation represents is 2 multiplied by pi, or 3.14, if you don't have the pi button on your calculator, multiplied by 1.4. So if I just type that into my calculator, it comes up with 8.79 6. However, we can just round to 1 decimal place and remember rounding. So this would round up to 8.8 centimeters. So always remember our unit. So 8.8 centimeters would be the circumference of our circle. And just on a little bit of a side note, I could have used this equation too. Both equations are going to give me, or both formulas, sorry, are going to give me the same answer. For this one, I just need to know what my diameter is, and we have our radius, so I just chose to use the one that I could just plug my radius into. But you can use this one too, because we know the relationship between the diameter and the radius. You just have to multiply your radius by 2. So if I really wanted to use this equation, I just need to figure out what my diameter is first before I can solve. So let's just do that. If I know that my radius equals 1.4 centimeters, I know that my diameter is just 1.4 multiplied by 2, which is 2.8. So now I have my radius and I have my diameter, so I could use this first equation up here. And I would just plug my diameter into that equation, which would look like your circumference equals pi multiplied by 2.8. And if you plug that into your calculator, you'll get the same answer as down here. So either of the equations work, you'll get the same thing. I just personally find it easier to use whatever number is given to me and then just plug that into the appropriate formula. And so just before we wrap up, I just wanted to kind of reiterate and draw out the 3 kind of main formulas that you'll need to know from this lesson. So the first, and we kind of already went through all of these, your circumference divided by your diameter equals pi. So that's the first one. If you're solving, your circumference equals pi times your diameter. And circumference equals 2 multiplied by pi multiplied by radius. So these are kind of the 3 big formulas that you're going to be using throughout this lesson. And what I suggest, as we go through, you'll kind of be getting more and more formulas for solving for an area of a circle, solving for circumference, solving for an area of a parallelogram, area of a triangle. So there's going to be a lot of formulas coming at you. What I would suggest is maybe you just have 1 page in your math book where you keep track of all your formulas, just so they're all easily accessible in one place. So that's the end of this lesson. Come to class with any questions or concerns you have, and you can work on the practice questions, which are on page 136 and 137 and outlined in your unit outline. Thanks for listening.